My name is Ajin and I'll be talking about automated mobile application security assessment with mobile security framework. Okay. So about me, I do security engineering at Iminio, and I'm the author of a couple of OWASP projects like OWASP, Synotics, and then mobile security framework, which I'm going to talk today. And I teach security via AppSecEU.com, and that's my blog. So the takeaways of today's talk is for pen testers, you get a free and open source tool that performs automated security assessment of Android and iOS applications. And similarly, you can make your life easier. And for developers, you can integrate the security practices in your SDLC lifecycle. And for web pen testers, you get a REST API tester, which is designed and built specifically with REST technology in mind to fuss and find vulnerabilities in REST APIs. Okay, so the agenda of the talk, I'll go through the architecture of mobile security framework, where I'll be explaining static analyzer, dynamic analyzer, the web API fusser. And then in the static analysis phase, I actually did some research, or I actually did some analysis on the top bank applications, both in India and Europe, and similarly some of the most important top wallet applications, both in India and Europe. We will see like what are the vulnerabilities which are common, which can be easily found, or and so on, and the observations. And then I'll be explaining the dynamic analyzer, where I'll be explaining how you can dynamically test for SSL-related bugs, then how you can find out exported activities dynamically, etc. And then finally, the web API fusser, where we actually fuss and find vulnerabilities in the API, and I will also explain like what is the logic that I'm using to detect these vulnerabilities. Okay, so what is mobile security framework? So mobile security framework is a complete end-to-end pen testing framework which is capable of performing static analysis, dynamic analysis, and web API testing of your mobile application and backend server. It's actually a product that you have to, it's not a product, it's an open source tool that you have to actually host it in your own environment. The reason, because I don't believe in trust, it's just somebody else's computer. So that's how it's designed in such a way. And let's talk about the architecture. It got a static analyzer, which can actually intake your Android binaries, that's an APK files, your iOS binaries, .ipa files, and even you can provide the compressed zip source code files. So it do a static analysis, nothing big deal over there. It's actually pretty much the same. You have a set of rules which it actually check for security issues and report you. So yeah, this is the architecture, where it actually the input is an IPA file or an APK file or this compressed zip file. It does a static analysis and give you an output back. And you can even generate report out of that, which you can actually add in your pen test reports. Let's see a demo before going into further details. It's a web framework written in Django, written in Python, which uses Django actually. So I'm just starting the server. So you can just drag and drop your APK files or whatever to the framework, and it will do the static analysis. So here is a vulnerable APK file. You can just drag and drop, and you can see the process in the bash terminal. It takes time depending upon the size of the APK. So it in fact actually support multiple decompilers and DEX decoders like njarify, dex2jar, etc. And here is a report that is generated by the framework. You can see the basic information about the application, like file-related information, then app information, the number of. So if you are from the Android space, you have activities, services, receivers, providers, etc. So it will list out the count and then those activities which are exported. And for those who don't know about export activities, it's something like a component which can be actually invoked by other malicious application or legitimate application, provided you don't have proper controls in your application that can actually cause security issues. So it will also tell you the code nature, what's the type of code, whether it is loading native code or dynamic code, etc., whether reflection APIs are used or not. Then shows you the certificate from where you can tell whether the certificate is good or bad, whether your product is actually signed by your company certificate or just a debug certificate. And signing with a debug certificate is not a good idea. And another thing you can identify is that if you see into the mobile malware space, what happens is like the hackers or the attackers, they actually download your bank's application, inject their malicious code. So the moment you actually modify the code, you have to re-sign it. You cannot sign it with the same certificate, so you have to re-sign it. So in such cases, you can actually, malware analyst can check for such occurrences. If the certificate is changed, that means your APK is tampered. That's the basic, the simplest check to verify that. Then simply it will list out the permissions used. And now we do the security analysis. We do the security analysis on the manifest file, which is Android manifest file, which actually tells you what is like the functionality, how the functionality of the app is, which are the views, which are the content providers, what are the permissions, etc. So we do a security analysis on the manifest file and give you the results where we actually tell you like what exactly is the vulnerability, where exactly is the vulnerability, etc. And moving down, we do the static code analysis. So this is basically a Java code analysis where we actually find out issues in your code. So these are some of the issues. You can see that application create temporary file, sensitive information should not be stored, etc. This is pretty standard, everyone knows. And we also do a file analysis where we actually check for sensitive files like certificate files, key files, etc. So oftentimes developers actually include security or sensitive key files. I'll show you a practical example of this issue. And again, the APIs used, the URLs used, and we also do a malware check. Like if you found an IP or a URL there, we actually do a malware check on those IPs and URLs, and the results is given. And then it results, and then it shows the contents of the file, etc. So you can actually navigate through the decompiled Java source code. You can click on View Java. You can search for something. You can search for anything, and you can navigate through the different Java source code as well. So this is just plain basic static analysis, just to get a feel of like how the static analysis framework look like. Now let's get back to the presentation. So I actually did a static analysis on a couple of bank applications. So I actually presented this research back in Nalcon. So it was in India. So the bank applications were of Indian bank applications. So these were the criteria which I actually put in forward to check an application, because these are the most common vulnerabilities that you see in an Android or iOS mobile application, like SSL bypass in native code and SSL bypass in WebView. So the reason for is like most of the security engineers here might know about it. Like when you're actually developing an application, you might be using self-signed certificate in your development QA or staging environment, and you forgot to move to the original certificate. I mean, so if you want to use self-signed certificate, you have to actually bypass SSL-related checks. So that if you do that, and later when the app goes to production, if you don't remove that code, that basically means you are not using SSL. It will actually accept any certificate. So such issues are there. These are one of the most common issues that you find in mobile application space. So another thing is weak crypto. So we actually know about crypto. People just go to Stack Overflow, copy paste the code, and that's your crypto for most of the people. So we actually see a lot of issues in crypto, like AES using with ECB mode. Then hash code is actually used. Java hash code is actually used for sensitive file information or sensitive things which are related to Java. Then again, things like basically some kind of improper crypto implementation with some uninitialized IVs, etc. Another thing is WebView debugging. So WebView debugging is a functionality in Android. Let's say if you have a hybrid mobile application that actually loads in a component, a browser-like component. So that's called a WebView for Android. And if you have WebView debugging enabled, that means if your phone is connected to a device and USB debugging is enabled, somebody can actually go through or debug through the different flaws of your application using a browser like Chrome. So those were actually used for debugging purposes, but not recommended in a production application. Then the typical hard-coded secrets. So these were the results actually. So the most common vulnerability, most common issue that we found was native layer SSL bypass. And then you have like web view level SSL bypass and remote level. So whatever is in red is bad, and whatever is in green is good. And this is actually a good thing to do, root detection. So a couple of them were having root detection. Most of them didn't have. And the face palm was that there is a bank which actually do SSL pinning. Everything is perfectly fine. And they actually hard code the certificate that they pin and the private key of their server. So that's also one interesting result that we found. I don't know. It's like too much of security. Then we actually did the same thing on some wallet applications, which are actually commonly used for recharging a mobile application or some wallet to store virtual money. Again, we have like similar issues found. Like the issues were mostly related to SSS. Okay, now coming to European banks, it looks like they are pretty good compared to what I have seen in the banks application in India. But the most common issue were weak crypto. I see a lot of AES crypto being used with ECM mode. Then what? Oh, sorry, not ECM, ECB mode. And SSL bypass were not there, but a couple of them, some big names were having that. I'm not disclosing the name or anything. I don't know what's the legal status here, so that's the thing. Then hard-coded secrets were also there, it's like OWASP secrets, some API key, API token secrets. So it's actually, in fact, quite hard to hide your secrets in mobile application, but there are like kind of way to prevent it from symbol static analysis. They were not even using those. Maybe because like obfuscation techniques and all will actually cause performance issues. Like let's say if the bank's customer is using a very older version or a device which is having less specs. So in that scenario, that may be the reason they are not using obfuscation. And this is the state of some of the wallet application. So they are actually a little bit better compared to bank application if you see the previous slide. And these were the observations. So the state of mobile security. The mobile security is not as evolved as web security. So if, let's say, if you scan like 10 web applications of top banks or top enterprises, it will be hard to find a single vulnerability, which is very critical. But if you do the same thing on a mobile application in a particular industry like finance or technology or banking, or medical, etc., you will be able to find a lot of issues in the thing. So that means like the industry is not so mature, especially the mobile security industry. And like I mentioned before, in the Indian apps, I see mostly SSL bypasses. And for European apps, it was mostly weak crypto and hard-coded secrets. And when you talk about bypassing SSL, so it's actually a pretty big issue. This is one of the real-world issues that I saw. This is actually a wallet app, which is very famous in India. So what they do is they actually do all the transaction in a web view. Pardon? Oh, okay. How do I zoom in? I think I have to change this display scale. Give me a sec. Is it better now? No. Oh my God. How about now? No, right? Okay, I cannot do anything. All right, so this is what actually happens here is they actually, if any error happens in WebView related to SSL, or before that, WebView is actually a browser-like component which you can actually use in your Android mobile application to load HTML, CSS, and JS files. So if you actually have this part of, this is actually an event handler which listens for SSL-related errors. So if any SSL error happens, just proceed. Ignore them and proceed. So which basically means don't use SSL. So let's say in a real world scenario, if I use this particular Android application and if the attacker is in the same network as that I am, he can just send any certificate, anything, it doesn't matter. Even he can send a different certificate or invalid certificate or whatever. Just to send that, my app will gracefully accept it and send you the, and do the communication so that the attacker can intercept the thing. So this is actually very dangerous. So you might think that SSL is there, it will protect, but often you have to make sure that they are not bypassed. So that's one of the most common thing you see in the mobile application. Let's talk about dynamic analysis. So for dynamic analysis, we only support Android application at the moment. So the input is the APK file, and you can actually do dynamic analysis in a VM, a configured VM, or a configured Android device, which is actually, we can actually pre-configure a device, Android device, to the dynamic analysis as well. So this is the architecture. So what happens is we actually install and run your APK in the VM or the device. We have certain set of agents running inside the VM to listen for the various activities. And at the same time, we actually start an HTTPS proxy to capture complete traffic. So if you're thinking about your mobile security assessment, you have to have an emulator, you have to connect it to the proxy, you have to install the certificate. So it's like a process. So it takes time to even to set up the environment. So here you don't have to worry about that. You can directly install and run the APK here. So our agents will run in the background. And again, once the analysis is done. So the intelligent part here is that you actually just have to go through the different flows of the application so that our agents in the background will learn from those flows and do security testing based on the flows which you actually navigated. This is very helpful when you are doing API testing, which I will be explaining soon. Now the results are actually collected back from the device or VM and is analyzed by the dynamic analyzer, and you will get a response. So let's see a demo. So here I'm just uploading a file. Okay, the static analysis result is there. Let's do dynamic analysis. For that, you have to click on Start Dynamic Analysis. So what happens is it will actually spawn up a VM if you're configured to do it on a VM. You can see the status over here. And now the VM is set up. You can actually create an environment, which will actually create an environment for setting up, like it will start the proxy, start the agent, etc. So you can actually see and monitor the process in the console right side. You can see that it's actually boot up the application. You can even see the screen on the analysis window. You can just click on Show Screen. That will actually show it. Okay, let me just set up this application. So now what I have to do is I have to actually go through the different flows of the application so that the framework can actually learn in the background what is actually happening. Let's say I actually go to app log settings. Then I actually change the log mode to pin. And I give a pin something like 4554. Okay, I'm just confirming it. Okay, the pin is recorded. You can actually go through all the flows, etc. So if there are more flows, let's do one thing. Let's click on Finish, which will actually finish the scanning and collect the result back from the VM, which includes application data as well as whatever assessments that we have done. So once that is done, it will actually generate a report like this, where you can actually download the different raw information. And it actually categorizes the data into what all APIs actually call. So these are the file I/O operations that were done by the application. So these are the file I/O operations. It try to open this particular file in this particular mode, etc. So it will show you the file I/O operations, and so on. Then the next thing is it also show you the network calls which are actually triggered from the application, along with the headers, etc. So these are actually done by API hooking. We actually hook all the APIs which are called by the particular application. And similarly, binder calls, the one that deals with the Android binder. And if any crypto is involved, we actually call those calls as well. If any crypto was there, it will actually show this particular string was actually given to a crypto functionality, etc. Similarly, there are different APIs that it will show. And You can see the traffic, the complete HTTP traffic is there, and the URLs which are dynamically visited. We again do a malware check on those URLs, emails which are dynamically collected. Then we do a file analysis. So in file analysis, we actually dump all the files which are created inside the VM to back into our host system where you can actually analyze. You don't have to connect it back and get all this, download all the files. The framework will automatically do it. So here is an interesting vulnerability in this application. So if you go down to one of the XML files, you can see that there's a string called patp, and then there is something which looks like an MD5 hash, which is nothing but the MD5 hash of your PIN. And you know that PIN is something between, it's a 4-digit number, so it's very easy to crack. You just generate the MD5 hashes of numbers starting from 111 to 999, and that will just give you the password. So here is a simple demo which actually shows you how you can crack that password. So you have to give the hash which you got from the file here. And it says hash not found. Oh, okay, sorry, I copied the wrong thing. It's actually pinp, not parp. So just run the script and give the hash there. And that's it. You actually recovered the pin. It's very simple. And next, so we actually saw a demo of the thing. Yep. So dynamic SL testing. So often, most of the times, let's say if the bank application is obfuscated, your decompilers may not help you. You may not be able to see if SSL is bypassed or not. But there is a feature in Mobile Security Framework which actually allows you to disable the proxy and all the SSL-related hosts. So if you're still able to decrypt the traffic, that means your SSL is bypassed. So that's a simple check you can do in Mobile Security Framework. You can just disable Just Trust Me, which actually bypass all the SSL-related checks and remove the certificate. If the connection still works on, that means it's actually bypassing SSL-related checks. Then there is exported activity tester. So you know about exported activity tester, right? So you actually find that out by analyzing Android manifest file. In fact, you can actually check. I mean, there are some manifest files which are kind of like obfuscated, but you can actually dynamically find whether the activities are exported or not. So just for the demo, you can go to one of the recent scans, let's say Diva, run dynamic analyzer. And create your environment. Okay. Now you can click on Start Exported Activity Tester. It will actually invoke all those exported activity and take a screenshot. So if there is any sensitive information there, you can actually collect that and get that in the result. So it started the exported activity and the testing is completed. So if you click on Finish, you can go to Exported Activity tab. There it will actually show you that 2 activities were exported. And if you see one of the activity, it actually contains some sensitive information like this. So that's that. Then moving on. All right, so when we are doing dynamic analysis, there are actually some challenges there. So some of the challenges are like some applications are written with anti-VM core detection. Then there is anti-root detection. Then anti-MITM detection or anti-MITM with certificate pinning. Again, like if you are trying to do a dynamic analysis in a VM, there might be some libraries or dependencies which are not there. There are things like AMP translator is not there. Some applications which are built for some APIs are not, they are not compatible, etc. So in such cases, you have to actually use a real device. And before that, we are actually trying to override most of the minimal checks by integrating those existing things like anti-VM root detection is actually bypassed using Android Blue Pill, which is actually an exposed module. So if you don't know about exposed module, it's actually It's actually a runtime instrumentation framework that actually allows you to override those Java methods with the methods that you define. So with that, you can actually bypass most of the things. And if they cannot do that, you can even do Smalley patching, or you can write your own custom expose module, etc. And for sophisticated malware, you have to sometimes, there are sophisticated methods to detect this, whether it's a VM or root or etc. So in that case, you have to actually use a real device. Mobile Security Framework also supports real device. You can run the MobSF script to start analysis on a real device. Okay, so that's the dynamic analysis. Now coming to the web API fusser. So when you talk about web APIs or REST APIs in mobile security domain, it's quite hard to do a security assessment unless you know like how the APIs are structured, what are the different APIs. So if you work for a product company, you might know about what are the different APIs and so on and so forth. You have the complete documentation. But when you're doing a black box testing, it's quite difficult. You don't know like what data is expected and so on and so forth. All you have is an app which actually generates some data, and you have to actually guess based on that. So what we do is, like, when we do dynamic analysis, we actually capture all the HTTP traffic, right? So we actually allow you to select a particular, it can actually include your analytics data which is sent to New Relic or Crash Analytics, etc. So you don't need to do a testing on those, which are not necessary. So you can actually select the scope of URLs, and there's a set of vulnerabilities that we actually currently detect. You can select the scope of the vulnerabilities, and then you can select which API corresponds to login, which API. So these actually are some specific things. There are specific things like with respect to the mobile environment, like PIN API used in mobile environment. It's not, you cannot see that in a web application. Mostly it's a username password combination. So we actually take those things in consideration. You have the login API, PIN API, register API, logout API. You can specify these APIs, and then the web app fuzzing logic will process, and it will give you the result. So let's see how we actually used to do fuzzing, how we did fuzzing of REST APIs. In case of testing web APIs of mobile applications, it's web app scanners or web security scanners is not really a choice. The reason is that your web scanners, how it works is like you have to actually, when you give a URL, it actually crawls through the different links, flows, etc. Yeah, and some intelligent scanners actually ask you to enter the login credentials or cookie, etc., so that it can actually know whether a session is there or not. But if you give a web API, or if you give an API which is a mobile API or mobile backend API, APIs does not have links. It just gives you a JSON response or whatever. So it's just some text-based protocol or responses. So there is no crawling, and that thing does not work. So your web security scanner cannot give much results if you just try to scan your backend servers. So there needs to be a proper approach. So we know that we have a general knowledge about most of the mobile applications. So most of the mobile applications have a login, a logout, register, a PIN, etc. So the logic is actually written with all this thing in mind. So it's kind of like a white box approach where we actually try to know some of the flaws of the application. And we already know from dynamic analysis that these are the APIs and these are the requests that should go. Again, data validation is not a problem. For example, there is a registration happening, and one particular field needs an email address. We already know the structure of the data from the request that we capture. So that won't be an issue. So we follow a white box approach rather than others. And we actually support detection of vulnerabilities like IDOR or insecure direct object reference, SSR for server-side request forgery, and XSE, among a couple of other vulnerabilities. Yeah, these are the lists that we currently detect with this logic, which is very difficult to find with typical web scanners. One is XSE, SSRF, IDOR, directory traversal or path traversal, some logical and session-related vulnerabilities. It's very difficult to detect logical vulnerabilities using scanners, right? They don't know like how the application is supposed to work, etc. So some kind of logical checks you can actually do. Some kind of things which are actually following a standard, we can automate that. Then we also check for API rate limiting, etc. So how we detect. So I'll explain how we do it. So this is the architecture. For vulnerabilities like SSRF and XSE, let's say the case of XSE. So how you verify a generic XSE is like you give an XSE payload, and if an entity gets expanded, that means there is an XSE, provided that the expanded entity come back in the response. That's very easy. Every scanners do that. But when it comes to out of bound checks, like you need a server. When it comes to out of bound checks where you don't get a response back, you have to actually do some kind of payloads which actually connect back to your server and verify that. So most of the scanners won't do something like Aconetics, etc. So recently, these features actually are incorporated into scanners very recently. We actually do that. So what happens is, anyway, we know the format of the request while doing the dynamic analysis. We actually replace, let's say if we don't actually fuss on all the body or the request, we only do intelligent fuzzing, because blind fuzzing your web app scanners can do. Why should we do that? So we actually try to see if the request body contain XML. If the body contain XML, we actually replace it with our XSE payloads or SSRF related payloads and send to the API server. If the API server connects back to our cloud server, that means it's a valid vulnerability. So that's how we detect it. Again, we actually told you like we don't like the concept of cloud. So this is actually an open source Python script file. You can actually run it on your own infrastructure, just that it needs to be in a public IP. So that you can verify and validate the result. Another thing is insecure direct object reference. So how we detect is like we make a request with proper. So in case of APIs, it's mostly auth header. Cookie is not really used in APIs, but some developers are actually still carry forwarding the cookie concept there. So let's say it's a auth header or cookie. So we make a request with this to the API server, we collect the response, and we do the same request without this auth header or cookie. So if we get the same response, that means we are able to access a particular resource, which is an insecure direct object reference. Another thing we do is like we actually allow, when you're doing the login in the dynamic app, while you're doing the dynamic analysis, we can do login 2 times. That means like do a login with the credentials of 2 different users. And what we do is actually we send a request with user 1's auth credential or header, and again we repeat the same thing with user 2's credential or header. If we get the same data, then again that's also a kind of like insecure direct object reference. So that's that, and we have session-related checks. So we actually know about your APIs, right? We actually try to access a resource. This is just basic symbol checks done by most of the scanners. We access the resource with the auth header or cookie, and then we call the logout API. So that means the session should be terminated. We again try to access the same resource with the expired cookie or header, and if you're able to access that, that means the session is not properly managed. It is still existing. So that's one way of verifying it. Then we have the rate limiter, which most of the mobile APIs won't check for rate. Since it is actually built on mobile, people won't think that somebody won't be doing a brute forcing on the login screen, or they do a bot to do multiple registration, etc. So those checks are mostly not found in mobile APIs. So you can actually do the brute force checking with rate limiter module. Other checks are like typical simpler checks like checking for security header, information gathering, directory or path traversal, etc. So we have a demo of that as well. So here I have an application. Okay, this is actually a vulnerable application. All right. Let's do the dynamic analysis. So in dynamic analysis, what happened? Okay, you have to create an environment. Okay, so the app is up. So now you can actually navigate through the different flows of the application. In this case, it's just a simple application which actually make a couple of HTTP requests. So you can click on generate traffic, where it will actually connect to internet and make some, some API calls in the backend, in the background. So once that is done, you can actually go to finish. Where it will actually show you the results of dynamic analysis. And the next thing is API fuzzing. You can click on Start Web API Fuzzer, and it will actually show you the list of URLs which are actually in the, which are captured. You can actually select whatever is in the scope, and then you can select what all vulnerabilities you want to test against. You can select those and click on Next. And now you can actually configure the login API, logout API, register API, provided that your application is having one. If it is not there, then session-related checks won't be done. So if you want to do session-related checks, you have to specify the login API, PIN API, logout API, etc. So once you're done with that, you can choose between basic checks or all the checks, depending upon the complexity and whatever your requirement. You can click on Start Scan. And meanwhile, in this terminal, you can see a couple of requests being made. And finally, you have the result. So it shows you basic information like information disclosure, which is can be done by any scanners. It also shows you the missing security headers. Some headers are not really practical in the mobile system ecosystem. But if, like, for example, these days, most of the companies are actually using the same API server for both your web application and mobile application. So in that case, it may make sense. And it actually detects vulnerabilities like XSE. You can see that this is a request that was done, which contain an entity that get expanded and came back in the response. So that's a symbol XSE. Then there is SSRF, and this is a request where it actually try to connect to the cloud. This is my cloud server with a particular hash running at port 8080. It tried to make a connection, and so that's why it's telling MobSF cloud server detected SSRF via hash method. And the classic path traversal vulnerability. So you can see the request was something like slash /etc password, and the response contained the contents of your password file. So that's the simple web API fuzzer. All right, so pretty much I cover most of the things. What's coming soon? I'm actually working on a Windows static analyzer and an iOS dynamic analysis of iOS application inside the device. So it's quite difficult to do it on a VM. Like they don't really provide a VM. It's kind of like simulator. So we have to actually do it on a jailbreak and iOS device. So that's actually under beta development. Probably at some other conference I'll present. And API fuzzer to support a couple more vulnerabilities like SQL injection and comics. So like comics and SQL map are actually kind of like the trademark or the benchmark tools for detecting vulnerabilities like SQL injection and remote command execution. So it's always not good to reinvent the wheel. When there are good tools existing, you have to use them. The only problem is that these tools actually expect a particular request or a particular parameter to be scanned. That problem can actually be solved by our intelligent API fuzzing. We know all the input points. Just that you actually collect all the input points, run them through these tools, and you can actually get complete coverage. So that's the advantage. Again, we actually allow you to export the proxy logs to other proxies like Burp or SAP or so on and so forth. These are some of the useful links which you can actually, regarding the project, you can get the source code, file issues, get the documentation. There is a video course. And these are my chunk bros I would like to thank who actually helped me in, getting this presentation done, getting a couple of components done, and that's it. Thank you. So if you have any question, you can fire up. Yeah. Okay, the question is something like, will the framework notify us whether the Mali code cannot be decompiled or not? Yes, it will actually. You can actually look out for the terminal where it will actually tell you like what is the status of the decoding. If it fails, it will actually give you, without giving like too much debug information, it will give you that this particular thing failed. If you want too much information, you can go into the log file and that will give you like this exactly failed. And there are cases that these decompilers and DEX decoders are not 100% perfect. So you can actually try with multiple of them. So we actually support, for DEX decoding, we actually support Dex2Jar, njarify from Google. For decompiling, we support JDCore, then what? Prockion, and so on and so forth. So you can even add your own tools if you want to. Yeah. Yes. Which one? Here, right? Okay, the question is like, what's a MD5 field in the framework for? It's actually for stored results. There are results which are stored, right? Or let's say the application is very big, So we actually give you a hash back, and you can actually later check for the result by the hash. I'll just show you simply. It's like typical web application flow, you know. Let's say you have an MD5 of the scan. You can just copy it and go to your home page. It's just a simple functionality. Give it there, it will directly take you to the report which is fetched from the DB. Yeah. Oh, by the way, I actually forgot to show you the report generation. You can click on download report. That will actually generate a PDF report, and you have the report of your pen test or whatever. Again, you have to manually verify. The tool is not to replace a human. It's just to make your life easier. Don't be lazy, and don't always trust tool completely. So that's my takeoff from this. You have to always validate the things. Yeah. Any more questions? Yeah. Pardon? Framework is able to detect the is the framework able to detect obfuscate code? That was the question. So, kind of like we have certain set of signature, I mean static analysis signature that were there to detect couple of commonly non-obfuscators, so that you can actually use a deobfuscator which is available or unpacker which is available. So it's not like we do the unpacking. We actually, allows you to detect or fingerprint which obfuscator was used. And based on that, you can actually, that will be actually shown in the finding as an info, which contains that this APK is actually obfuscated with this particular code, and you can actually, use the particular deobfuscator to deobfuscate that. Yes, sir.
Sorry if you talked about it, but do static analyzers find things like intent injection or SQL injection?
Yes, so intent injection or SQL injection. So that's what I'm telling. So the code analysis phase, so I'll give you example like this. In static analysis, it will tell you like where raw SQL queries are executed. You have to go there and manually verify it. In dynamic analysis, it will tell you like what exactly is the query tell. So you have to actually find out whether injection happened or not. It will point to all the places where a possible injection can happen, where user input will come in directly. So that means, let's say if the user input come from one of the view of the application, that's an injection. If you want to see a demo, I can just show you that. There is actually in the, so let's say you have this application, and one of the security finding is something like, where is that? Yeah, app uses SQL database and execute raw SQL query. Untrusted user input can result in injection. If you go to one of the activity, this is your plain old SQL vulnerability, where a parameter from a text box was received and directly put into the processor. Yeah. Any more question? First of all, yeah, the question was like the framework looks kind of like similar to Quark. Okay, so I don't know much about Quark, that is one thing. The other thing is like Quark is more of it actually find vulnerabilities in it's kind of like browser. It actually find issues in your application and generate and exploit for that, I think. This is not like that. It's just a pen testing framework which is capable of, it won't generate exploit, it just find out issues or pinpoint you or show you like where an issue, you can find an issue. Yeah. Any more question? Yes. 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 All right, so the question is something like when we are doing a testing, are we actually collecting the complete HTTP request flow and then doing the testing, or just we are doing on a particular request? Yes. Yeah, currently it's very limited. Like these kind of flows are actually applicable for session-related checks. Let's say like you want to actually check whether a particular thing is, a session is validated or not. You have to actually call the complete flow, the multiple login calls. So some standard checks that we can do, we will do. But others thing is more like you can actually click on any button and it can generate any flow, right? So that's something that's not something that we cover because it can be any flow. So we don't have a proper way of structuring. Otherwise, you have to have something like a machine learning algorithm or something of that sort. But some kind of improvements where we can, where there's a standard exists, we can always automate the things. But when there is no standard, it's quite difficult. All right, thank you.